So first, let me say thank you to everyone that's on the other side of the screen. I know that we are on a Saturday and we've been living a couple of difficult times, so it really matters a lot for you to attend to my talk. I also want to say thank you to the organization. You've all making an amazing job. It's not easy to organize an event, especially one online. So before I start, let me just say thank you to everyone that made this possible. So thank you. It's not awkward to clap on an empty room, but let's start. So hello everyone. My name is Carlos Mota. You can find me on Twitter at Mota. I usually tweet about Kotlin, about Android, about photography. I'm also the founder of GDG Coimbra. I've been writing for Hey Wonder League. I have this dream of one day creating a podcast. So if you also have the same dream, talk with me at the end. I love to travel, photography, and running. I've also been working with Android for the past 10 years and for multi-platform for the past two. I've created some materials for this talk. You can find the source code at GitHub and the slides at my speaker deck. And I've also created a code lab for you to create your first multi-platform application targeting Android and iOS. And basically, it's a code lab where you can go step by step and creating the network layer, the parser, everything. It also has a last section where you can migrate your existing applications to multi-platform and also a troubleshooting section in case you have any problem and well, you need a solution to solve it. If none of the solutions work, feel free to reach me on Twitter, for instance. I think this image really sums up the problem with mobile development. If on the one hand, on the left, we have this amazing castle that represents the beautiful applications that we make natively, it also means that before you can reach that castle, there is a huge maze to maintain and create a native application. The application will be fluid, will have amazing animations, but before we reach that state, we have a long path. If you go for an hybrid or a cross-platform solution, it's easier to create an application and to launch it. But if you look at the end result, we're going to see a house that we're not sure how long it will last, but it's still there and people can use it. We've been seeing several solutions for this since 2006 when PhoneGap was launched. And we've been seeing solutions like Xamarin, Rubymotion, Ionic, React Native, NativeScript, Kotlin Multiplatform. And I'm saying between codes because it's not really a cross solution, as you're going to see. And most recently, Flutter. Of course, that cross-platform solutions and the hybrid platform solutions have several advantages. The first one, and probably the biggest one, is that you only need one team. Although I advise you to have at least one person from iOS and another from Android, typically you can have a team from people from the web. Since the languages are pretty similar, they can start developing mobile using one of these frameworks in no time. Since you don't need two teams and you're going to reuse the same code base between both platforms, this also means that you're going to have less costs. It means that you're going to build your application faster, it will be faster to test it, and hopefully you're going to have less issues. Probably the ones that you're going to have will be more difficult to solve, but ideally you're going to have less ones. Of course, this also has a lot of disadvantages. For me, the worst one and the one that I've been through, it was some years ago. I developed an application using Xamarin and it was launched for iOS. And iOS decided to make this huge redesign where the native components, when you updated to the newest iOS, would be totally different. And since we're talking about iOS, let me say that on the upcoming days where a new operating system is launched, typically 80% of people update to the new version. So it means that a lot of people were still seeing my old version. This means that a lot of people uninstalled my application and I could see the installation dropped. Why this happened? Because when you're using one of these frameworks, you're relying on widgets created by the framework. So I needed to wait for 3 or 4 months before Xamarin launched the newest versions. I needed to recompile my app, I had to submit it to the store, and hopefully people would update it. This also means that if you're running this application on an older device, you're going to see this new UI, so things won't be consistent after all. I noticed a few days ago this exact example on an application that most of us use that called Instagram. I'm not sure if you notice, but let's look again to this spinner. Not this one inside the dialog. This is like Android 2.1, 2.3. I almost don't remember seeing these grayish dialogues on Android. This was like 10 years ago, and no one decided to update this part of the login process. Another point here, negative one, performance is not the same. I know that this is always really subjective, but you've got a new layer there, so you're always going to lose performance. Sometimes you need to write native code. If one of the platforms doesn't support a specific feature, typically it's not created on the framework and you need to implement it by yourself or asking for the community to create it. Dart, it's not a widely used language. It's gaining a lot of attention, but you cannot compare with Kotlin, for instance. And you're committing your entire project to one framework and one language. And my question here is, what's going to happen in 5 years or 10 years? Will that framework still exist? Or are you going to need to rewrite your entire application because there is no longer a framework that is continuously being updated? You need to think with all of these points before selecting one of these solutions. And this depends a lot on your project. If you want to create a proof of concept or an MVP, let's say, one of these solutions, it's good to create a really fast application for both platforms. But thinking in long time, at least for me, it's not the best solution. So how about Kotlin Multiplatform? I say that it wasn't really a cross-platform solution. This is because Kotlin Multiplatform only wants to share the business logic. It doesn't care about the UI. UI should be done natively. And there is a huge question here if you should do the UI using one of the cross-platform solutions. I tried doing with Flutter, so I had a shared model created on multi-platform, and I was using Flutter with this. It's not easy to have everything together. Honestly, on my point of view, it doesn't make sense to have Flutter on top, although it's possible. Not only me, but there are a couple of projects with it. If you want, go check it out. So talking about the disadvantage of cross-platforms, and we go to multi-platform, this no longer applies. We're going to develop the UI natively. So if the OS is updated, the native components, of course, will be updated. Well, performance of the same is always arguable, but you're leaving everything for the UI to native, so it's going to be the same. You're going to have a bit of increase on compilation time, especially on iOS side. Although this is on Kotlin's roadmap, on JetBrains' roadmap for March, it's to improve the building process. Some native code needs to be written, of course, the UI. You have access to everything. If you want to use multi-platform, you need to do this on a shared model. It will be a bit more difficult, especially in the beginning, but as soon as you're used to it, you're going to see that it's faster. It's the same speed to develop. And of course, Kotlin, it's one of the strongest languages nowadays, with a really strong community support. So since we're talking about Kotlin, we're going to have Kotlin on server, on web, on Android, on native, on desktop. You can have Kotlin on almost every platform. So you can take advantage of all the Kotlin features. It's Kotlin first. It's low risk. It's you who decide what's going to be shared. I follow the same approach here than when I switched from Java to Kotlin. I started by creating unit tests for a new feature on Kotlin and now on multi-platform. And then when a new requirement arrived, I started creating the network layer. And then I created the parser and so on. I was making small features, small requirements, one out of the other, until I had totally one feature doing on Kotlin Multiplatform. And from then on, I've been using Kotlin Multiplatform on a couple of side projects, and I've been really happy with the result. It gives you interoperability, it gives you consistency across platforms. I had these discussions so many times. I'm from the Android team and I have people on the iOS team, and we've implemented something. But as on Android, for instance, we've implemented a cache mechanism and we're making a request to server, but the iOS didn't implement it. So we can see different behaviors depending if you're running Android or iOS. If you're going to do the code with multi-platform, you're going to share this business logic. So all the platforms will behave equally. This also means that if you have a bug, you're going to have a bug on all platforms. But if you see the cap as half full, This also means that we're going to fix a bug on all platforms. So this is good. Of course, there is also a strong investment from JetBrains, from Google on Kotlin adoptants, from the community. If you have questions, you can go to Kotlin Lang Slack. There are people answering your questions almost 5 minutes after you make those questions. Of course, it can take a bit more, but you always have a question, and people are there to help you, not only from JetBrains, but from the community itself. A question that I heard a lot of times is that there are already apps on production. This slide is from December last year. And from December, well, Kotlin Multiplatform is no longer experimental. We've reached alpha. And we've got applications on production since Space. It's full Kotlin Multiplatform. We've got Cash App, the creators of SQL Delight, that decided to share their business logic. Index Maps share their business logic and the wrappers for C++ libraries. PlanGrid shares their business logic, sync logic, and management offline data. Other applications share other parts of their apps. So this is the point of Kotlin Multiplatform. You share what you feel that it's right to share, what you can share, and start sharing small parts, and don't dive in and just share everything. Start small, just to see if you and your team get custom with multi-platform and if it's the future for your applications. So let's develop a multi-platform application for Android, iOS, and the web. So multi-platform means that you're going to use Kotlin projects that target more than one platform. Easy, right? So let's see this example. You're going to build for Android, so you're going to create a presentation layer, a model, a parser, a network, and then you're going to implement the view. And now let's imagine that you're going to create an iOS application, and you're also going to create one for the web. So we're going to do the exact same things on all of these platforms. But if you look at the business logic, it will always be quite similar. It's the same logic behind each one of these platforms. So why don't we share it, right? We can share this business logic and save up a lot of time and create consistency above all platforms. So how can you start? You could use IntelliJ, or now you can use Android Studio with this Kotlin Multiplatform mobile plugin. You can compile for Android and for iOS from Android Studio. And to install it, you just need to go to Preferences, Plugins, Marketplace, Kotlin Multiplatform mobile plugin, restart Android Studio, and that's it. It will be automatically installed, and from now on, you can run your multi-platform code. So I've been talking about this, but how can there is code that is specific for Android and for iOS? For instance, let's think about shared preferences. On Android, they're called shared preferences if you want to store data there. On iOS, they're called NES user defaults. Or if you want to use the logger, for instance, on Android, we access the util.log class. If you're going to iOS, we call the print. If you go to the web, we can call console. So how can the multi-platform model know which function, which method should it call? And I don't want to ship iOS code on my Android application, and I don't want to ship Android code on my iOS application, and I don't want to have something like if Android do this, else if iOS do that. No, I only want to have the Android code on my app. So this is fairly easy. You need to use the keyword expect, and you define this on a common model. You're going to have several models. You're going to have your applications, Android app, iOS app, web, and then you're going to have a shared model with your common model and your platform code. And it's on your platform code that you say what expect actually means. So you're going to use the keyword actual to say what that field really means. But let's see an example. Let's imagine that I want to say something like hello Android if I'm running on Android, or hello iOS if I'm running on iOS, or hello web if I'm running on web. Let's go a bit further and get the device name. So we open our common main, and we say that we expect someone that's going to define what name really means. If you look here, I'm inside shared folder, so I'm going to share all of this code, and the common main means the code that is shared across platforms. If I'm targeting Android, iOS, and web, automatically you see an underline, a red underline under platform saying, okay, you need to define what name really means. And if you press Alt-Enter, automatically it will create your files with everything, and you just need to say what name really means. Here, we've moved to Android main. So we are on our platform-specific code, and I'm going to access the build manufacturer. So I'm accessing SDK and Android SDK feature, and I'm going to say that name on Android means manufacturer. Now, if you go to the iOS, for this I'm going to access UI device, and on iOS main, I'm going to say that name really means UI device.currentDevice.name. Now I can go a bit further, and let's go to the web. And here I'm going to define on GS main, and I'm going to use the window navigator and get the user agent to know what browser I'm running this application. So if I'm now running this code, I'm going to see hello Pixel XL, hello iOS simulator, or hello Google Chrome if I'm running it for the browser. So how's everything structured? So you've seen the shared model. We also have an Android app, iOS app, and web. This is where your application code is. If you open this Android app, you're going to see what you're already familiar with. You're going to see the source, main, Java, or Kotlin package name, and then you're going to have your activities, your fragments, your resource, like strings, drawables, etc. If you open iOS app, you're going to see your Swift code. If you're going to open web, you're going to see your HTML, for instance. If you open the shared, you're going to see this common main. It's where the expect is and all the logic that's going to be shared exists. And then if you're targeting Android, we're going to see Android main, where you're going to define the platform code. And of course, if you're targeting iOS and GS, we're also going to define our platform-specific code there. So let's get everything together. I'm guessing that you're already familiar with the build system, the build.gradle. So this is quite similar for what we use in Android. So first we need to define the common main, the shared model. So I'm going to use libraries like Ktor for network accesses, Kotlin serialization to get a response and to parse it for a JSON object. And for an object that I can use, I'm going to use coroutines, SQLite for the database, and multi-platform settings for that shared preference and yes user defaults. If now I want to add the Android part, I'm going to call Android on the top, and I'm going to define the dependencies for Android main. Now imagine that I want to define for iOS. I'm going here, I decided to separate between iOS simulator and iOS device just for the building process to be faster. So I won't create two frameworks. Here it's going to create the iOS x64 if I'm running on the simulator and not two frameworks that I could use. It also has a CocoaPods integration. I could add here something like Firebase Firestore to download this library and install it. And finally, to use the libraries that I'm going to use on the platform side for iOS, I just need to call iOS main and add those libraries. If now I want to go to the web, I just need to call the GS and once again define the GS main and all the libraries that are going to be used. So briefly, all your common model or your expect is defined inside common main, and then depending what you're targeting, you should define what actually it really means inside Android main, GVM main, native, or GS main. So we've been seeing a lot of theory. So let's see a bit of code first. So let's stretch out a bit and let's see the application that I've built. Basically, this application gives you the conferences that are going to happen nowadays. It's from Android Study Group, and it allows you to also select the ones that you want online or not. So this is the Android UI. I've got here the iOS UI, and now this is the web UI. And I think you can know that I'm not a web developer. So if anyone wants to improve this, please be my guest, make me a PR that I will kindly accept it or happily accept it. But how does this work? So basically, I'm making all this shared code like network requests, parsing, store it locally using system preference. All of this is done on the shared library, and then I'm implementing the UI on each one of these platforms. So if you look at all the platforms, typically for Android, you use for database Room, for iOS Core Data, for network access, retrofit, alarm of fire, JSON serialization, RS Java, RS Swift. And if you go to the web, I tried to make these questions to people that really understand more than web frameworks than me, and it was a really strange fight. Web has a lot of frameworks out there, and everyone tries to say that their framework is the best. So are just some examples, like you use Redux, Fetch, JSON-API Serializer, etc. But we want to merge everything, so we're going to use on this business logic, SQLite, Tor, Kotlin serialization, MVP, Kotlin Next for routines, Kotlin tests, and then we're going to implement our UI using our already known activities, UI view controllers, web components, etc. So basically, this is the high-level model of diagram of our application. And let's just merge everything into this platform-specific. And I think that's worth to mention is with the newest version with HTTP client, you don't need to define the engine. So you don't need to have platform-specific code for having HTTP client running. So let's see this example. I want to make a request to a server. In this case, it's going to make a request to my GitHub gists. So I'm going to create an HTTP client and I'm going to make a get there. And I'm going to use that URL. Something that you're going to see here that's a bit different, it's that I'm saying that I'm going to receive a string. This is because of a limitation that we have on the GitHub gists, that I've created a JSON object, but the content type is text plain. So basically I will receive a string and I need to parse it afterwards. But there is no problem, I'm going to do it on another layer. So here we've created a method to access the network using the HTTP client. We created the conference object that is going to be serializable. It contains simple things about the conference, like its name, the FS Italy, city, let's say it's going to be Italy and country also Italy, date today, your logo, website, and status would be online. So now that we've created all of these, we need to create the methods that are going to call this and process this data. So I've mentioned that this needs to be parsed. So we're going to first call the fetch conf that we created before from conference API. Once we receive this information, we're going to call JSON decode from string. And we're going to say that we expect to receive a list of conferences. With this, we're going to call with this list of conferences already processed, we're going to call on success, and we're just going to send those conferences. Of course, that you could and you should add this between a try catch, because if you don't have network, the fetch confs will fail, and you should call on failure on that case. Now that we've defined on success, let's create a way for our UI code to access our shared model code. So first, we create an iConference data. This is an interface. It has two simple methods, one that says conference data fetched, and the other that says on conference data failed. Conference data fetch receives a list of conferences that we're going to use to call our table view or our recycler view to update the existing conferences. Now we also create an attach view method. This is the method that's going to be called by the UI, and it's going to send its interface. Now that we have the UI interface, we're going to call the get conferences that we created before. And if you see here, I'm saying that when on success it's called, it's going to call view.onConferenceDataFetch. So it will trigger the method for the UI itself that will, in the end, trigger the recycle view or the table view to be redesigned. If anything fails, it will call on failure that in terms is going to call on data failed. Now that we have everything here created, we need to initialize them. And we need to create a method, an object that the UI can access without any problem and without having to always be creating the same object. This is an heavy operation after all. So we create our conference API, we create our get conferences, and now we create a way to get our conference list presenter that we created before. With this, we now can call from the main activity, for instance, or from our view controller. We can create this getConf presenter, and then when we want, we can call that touch view that will trigger the fetch conferences, that will trigger the call to the conference API, that when we receive that response, it's going to be parsed on get conference, called on success, and then we're going to receive it on this on conference data fetched. And then we finally update the UI. We're going to read this a lot of times. Every time you compile a project, you will see a message saying Kotlin Multiplatform's project are an alpha feature. This is right, and this is especially important every time you want to make an update. Since you are targeting several platforms, it might happen that you update a library and you broke something on another thing. For instance, if you're going to use Ktor native MT2, and if you have a web project, you won't be able to compile it. So you need to take special account when you want to update something. The project that I created, it's using all the latest libraries. It already targets Kotlin 1.4.10. So you can start it with it as a code base and use it as a template for your applications. Don't try to reach 100% from one day to the other. Start small, start by sharing small logic, start by sharing unit text. Imagine that you're processing an image, try to share that image processor. Let's try to share the network layer, start small and make small increments to see if it makes sense for your project. So another big question here is that how can you convince your iOS team? You might spend some time trying to convince them. There is a really good argument, I think it's from Kevin from TouchLab, that says, well, core data, it's not particularly, let's say, an happy feature that they have on iOS. So tell them about SQLite, and you'll see that they're going to love that library and they will be really happy to change. This is one argument. I've made some tests with my friends for iOS, where I basically gave them a shared model, and they only needed to implement the UI, creating here some kind of front end, back end. And they love the idea for just focusing on the UI. They could create some more animations. They could create better components that they weren't used to because they didn't have time to do everything. And for them, don't having that work of dealing with the server side, with this business logic, they really love this experience. Once again, Kotlin Multiplatform, it's not intended to share the UI, so don't try to share it. And you can now debug it from Android Studio, although there is also a plugin from TouchLab that allows you to debug it from Xcode. You've got a really strong community. A lot of people are using Kotlin nowadays. Google is pushing it. I think, if I'm not mistaken, all the application code that's launched, it's now on Kotlin. It's no longer Java. You can ask any question on Kotlin Stack. People there are really, really friendly and they're really, really helpful. If you look on the big picture, since you're going to share a lot of your code, you're going to save a lot of time developing your applications. You don't need to write your application unit test twice because you're going to share your code, or probably should create one or two, but most of them is going to be shared. And you have an amazing advantage here. You're going to have one tech stack. You're going to have consistency across platforms, and you only need to care about one business logic. Some libraries that I've used and are available: you have Ktor Network, Routines, Serialization, SQLite, Multiplatforms, Settings, Stately. Some cool projects to follow, especially you've got People in Space that also has an WatchOS application. You've got the Camp Kit from TouchLab that's really, really good. Some more links. You've had this week the Kotlin online event. These 3 talks are just focused on multi-platform. They talked a lot about multi-platform. TouchLab also made a recap about these talks with their insights. They're really strong with multi-platform. So if you're curious, go watch those links. They've also mentioned that I've created a code lab where you can see step by step on how you can create your multi-platform features. Feel free to access to it. It's available. It's on my GitHub. You also have this last section where you can migrate existing code to multi-platform. And some final links. You can access all of this information from my speaker deck, from my GitHub, and of course from my GitHub page with this KMP code labs.
Okay, thank you, Carlos.
Thank you.
We have 2 now. I'm going to share my screen. Okay. Can you see? Yeah?
Yes.
Okay. First one is, which is the trade-off between performance and cross-platform? In other terms, in which use cases it is better to avoid cross-platform?
Well, in my opinion, when you try, it's not only on performance-wise, but it's how your application will look. But if you try to have different applications created on multi-platform, on cross-platform, and compare them with native, you see that you don't have the same sense of animation. Sometimes animation seems that they lag, and if you start to have devices, for instance, I have a Pixel XL, the device I think has 4 or 5 years, and I can easily notice when an application it's not doing native because the device starts to be a bit slow and I can see the animations lag a bit. And also when you interact with an application, sometimes you don't have that immediate feeling. Things took a fraction of a second that when you're used to develop natively, you can almost spot them on the other applications. Being said, I know that Flutter is really strong on this and it's really improving. So this depends a bit on the framework that you're using. If you go to the hybrid platform solutions, you can see it really, you can spot it. If you go to the most recent ones, you're going to notice that it might depend on your device.
Okay, thank you. The second one is, are coroutines production ready at the multi-platform level? And if not, how risky is it to use them in a KMP project?
I'm laughing because this week or last week, I've been creating these sample projects, and I wanted to make a huge applet on a part of the project, and I had a problem with Ktor and coroutines when I was using the web because I needed to use different versions of the coroutines to work on iOS side. Otherwise, I would have an exception. But I couldn't update this to run on iOS because in that case, my GS model wouldn't be able to find the corresponding version. So I think they're ready. They're starting to be stable. You're going to spot several errors still on iOS, and it's not that easy to spot them, to debug them. On my opinion, you should start doing it. Try to find a stable version between all your platforms, and don't be like me that always wants to run the latest version. If you find, let's say that the planets are aligned with these platforms and versions, keep with them. Don't go after that to update it. Once you manage to have this the same version, I think they're pretty stable. You can sometimes find one or another issue, but typically after some hours, let's say, of debug, you can spot the issues.
Okay. So thank you.
Sorry, just a small thing. So about risky, I would say that middle risky.
Okay. Okay. Perfect. So thank you, Carlos, for your talk. So we are just finished. So and see you later.
Thank you everyone for being on the other side, and thank you for having me. And see you later.
Yeah, we are presence next year.
I really hope so.
Bye bye.
Bye. Thank you.